All right, we're back with Parabolas Part 2. When we left off, we had this messy looking diagram that described the different pieces of a parabola. We saw some examples of parabola in real life, and we came up with the definition that a parabola is the set of all points in the plane that are equidistant from a fixed point called the focus and a line called the directrix. So the focus being the point right here on the parabola, the directrix being this line down here, and the parabola is all points equidistant to them. All right, so what does this actually look like to do and to make a graph of it? Let's take this example, x squared equals 12y. Let's see how we do this, and work right along with me as we solve this and we try to graph it. So we're going to try to graph this. All right, and to do that, we'll pull into play all the vocab that we learned in the first video. So let's look at our general form. X squared equals 4py. That's really helpful because that little variable p right there is going to be helpful in finding several of our key elements. So if you can reference your notes while you're doing this, it would help you a lot. Let's take that 4py piece. Let's compare our two graphs, and what's in the place of 4py? Well, it's 12. So 4py equals 12. Whoops, not 4py, sorry, just 4p. And I'll use a different color here. So 4p equals 12, which means p equals 3. That will be useful for us. So p equals 3. Now what can we do with that? Well, we know that our focus, let's plot that. Our focus is 0, p as a point. And it's important to recognize, again, the x is squared, so we know that this is going to be a vertical. This is a vertical parabola, and also that 12 is positive, so it's going to open up. So this will open up, and so that p back here we know has to be on the y-axis. So our point P is 0, 3. So let's go ahead and plot the focus right there, 0, 3. Good. All right, so the focus is at 0, 3. Let's change colors. Let's find the directrix. The directrix is the line y equals negative p. So in our case, this will be y equals negative 3. So let's find negative 3. Let's make a line down there. Let's see if we can make this dashed for us. And lost my line. All right, here we go. Good. All right, let's make that line down here at negative 3. Didn't dash for us, so that's okay. There's our line. That's our directrix down there. Y equals negative 3. And so the parabola has to be all points equidistant from both of those. Now, our vertex will be 0, 0. We know that because there's no translation. So our vertex is 0, 0. Now, when we start adding h and k, we can move this parabola around. But for now, vertex is 0, 0. All right, and the last piece that will really help us plot this is the focal diameter. Focal diameter uses that variable p that we found. So the focal diameter is the absolute value of 4p. So in our case, that's just 12. So what that means is we will need to count 12. And really what it ends up being is 2p in each direction. So if the whole thing is 12, then we'll have to be 6 on this side and 6 on this side. So if here's my focus, I count 1, 2, 3, 4, 5, 6. Right? And then the other direction, 1, 2, 3, 4, 5, 6. And there I have my focal diameter. So if I can connect a parabolic shape from the vertex through those points on the focal diameter, then I've plotted my parabola. And to label the pieces, here's our vertex. Vertex is right there at the bottom of the parabola, as we already know. Our focus is this right here, and the focus coordinates are 0, 3. And finally, we have our directrix, and that equation is y equals -3. So there's an example of solving one. Let's look at two more, one vertical and one horizontal, that maybe get a little more complicated. All right, so these are your key terms on the left, and this is the vertical axis. So for us to take some great notes here and have a great example to look back on. So let's look at this example. Let's look at x squared equals -6y. So we'll throw in a negative in there, and we'll make this maybe a little more complicated. Now, since it's x squared, we know that this is vertical. We already know that. And since 6 is negative, this is going to open down. So our general shape is going to be this. We know it should open down. So that will be helpful. We also know that there's no translation, so the vertex is going to be at 0, 0. So right off the bat, we can start plotting some points. 0, 0 right there. Okay, now let's start manipulating the equation we've been given to find the other elements. Now remember, our general formula we're using in conic sections is x squared equals 4p y. So if we wanted to find p, in our case here, p is -6. So 4p equals -6. And if we divide by 4 on both sides, p equals -6/4, which is the same as -3 halves. So it's messy, right? We're dealing with a fraction and a negative at the same time. All right, so if we go over to our focus in this case, since we are vertical, our focus will be 0, p. So in our case, the focus will be 0, -3 halves. All right, so I have to find that on the graph. Now 3 halves, that's the same as, you might want to do this on the side. 3 halves is the same as 1.5, right? So I'll go and find, I guess it's negative. So we'll find 1 and then 1.5 right there. If we're counting each box as 1, which we will in this case. Okay, the focal diameter. The focal diameter is just the absolute value of 4p. So if 4p is -6, then in our case, it's +6, and half of that would be 3. So we need to go 3 to each side of the focus. So let's count 1, 2, 3, and plot a point. 3 to the side of the focus, and then 1, 2, 3 to the other side. Because now that distance, right, that distance between them is 6, if we count the boxes. All right, finally, our directrix, let's do that in red. The directrix is y equals -p. So in our case, it is y equals 3 halves, +3 halves. So we will make a line at +1.5. And let's see if we can make this happen this time. All right, I'm going to try this at 1.5. Nope, that just ended up moving my graph. Still getting used to this technology. Okay, here we go. Let's just do this. Let's draw this line at 1.5. Well, it worked that time, but it's not red. So there's our directrix at about 1.5. All right, now it's time to draw the actual parabola itself. So we have the vertex right there at the origin, and then we have our focal diameter set. So we just need to connect a parabolic shape through the vertex, from the vertex through the focal diameter. And that would be the shape of this parabola, x squared equals -6y. All right, so it's a great example because we have a fraction and because it is a negative, it opens down. So you'll run into stuff like that. So let's look at an example of a horizontal parabola. For this one, can't clear my screen here. Oops. Hang on a second. There we go. Okay, for this one, we will look at the equation y squared minus 8x equals 0. So this one throws in another element. First of all, we have a y squared term, which is different from what we've seen. And second, we don't have it in the standard form yet. So this will be a good challenge for us. Now, first of all, first thing to recognize, as soon as you see that y squared, recognize this is going to be horizontal. It'll be horizontal. Now, we're not in standard form yet, so we don't know which way it's going to open. Well, I think you can see, you all are very smart. You know which way this will have to go. What we'll have to do, we'll have to add 8x to both sides, and so we'll get this in the form y squared equals 8x. Now this is in the form that we can use. So we have y squared equals 4px, and we see that 8 is in the place of 4p. So if we wanted to find p, 4p equals 8, which means that p equals 2. So now that we found p, or gold, we can start filling in our different elements. And looking back at our form that we came up right here, y squared equals 8x. 8 is positive, so we know that this will open, in this case, to the right, since it's horizontal. So this should open to the right, which means we'll have something like this going on, except it will go through the origin. Now again, there's no translations going on, there's no h and k, so our vertex is at 0, 0, just like last time. So let's go ahead, plot the vertex. Now, what about the focus? Now the focus will change, so recognize this. Make sure that you've highlighted this. It'd be great to take this column right here for horizontal axis and copy these down in the general form. The focus for a horizontal parabola will have a different form, will have a different point. Instead of lying on the x or y-axis, it will lie on the x-axis. So this will be p, 0. Now in our case, p, 0 is 2, 0. So again, p, 0, that's different. When it was vertical, it was 0, p. So here we are at 2, 0 for the focus of our graph. Okay, now how about the focal diameter? Focal diameter is still the absolute value of 4p, so that will be 4p is 8. So we need to be 4 on each side. Now remember, we're opening right, so we're not counting horizontally, we're counting vertically in this case, meaning 1, 2, let's see, we need to get to 8, 3, 4, so it'll be 4 on each side. We want that to be a total of 8 right there. And we have our focal diameter, and that will help us plot. And finally, the directrix. The directrix is, in this case, it is a vertical line. It's not a horizontal line. So instead of y equals, it's x equals negative p. So for our graph here, it'll be x equals negative 2. So we come out to negative 2, and we draw a line at negative 2, and that is our directrix. All right, so now it's time to fill in the points. We start at the vertex, and we draw a parabolic shape through the focal diameter. If I wanted to label these parts then, I have the vertex is right here at the origin. The directrix is this line right here at x equals negative 2. And finally, our focus right here at 2, 0. So there you go. That's a great idea, great intro into how to graph both a vertical and horizontal parabola in conic sections. One more thing to look at. This is a question I'd like you to answer before you come in. Look at this question and write this out in your own words, right with your work. List the steps for graphing a parabola in x squared equals 4py or y squared equals 4px form. List the steps. Make yourself in ordered steps, number them, make it clear, make it concise. So if you were, think of it this way, if you were teaching someone else, how would you explain it to them? All right, good work, y'all. We'll see you soon.